Hi friends, see in kinematics 2D problems, we have seen rain umbrella problems. Now let us see in the last part of kinematics 2D, that is case 3. That means when rain is falling at some angle around 37 degrees and man or woman moving with 30 kilometers per hour in this direction. Now how to solve such last problem, last case. So in this case what you have to do is you have to solve the components. So rain will be having two components, one is vertical and this is horizontal. So rain is falling at 40 kilometers per hour అంటే ఏంటి అర్థం, vertical component ఎంత అవుతుంది 40 sin 37 and 40 cos 37. So we all know the famous triangle 37 3 4 5. So from this what is cos 37 adjacent by hypotenuse 4 by 5, sin 37 opposite by hypotenuse 3 by 5. In the same way you know what is 53 also if you want, okay, but here 53 is not there, you need not. So for 37 you can go like this, cos 37 4 by 5, sin 37 3 by 5. Clear? Now the components how much will get here, 40 into sin 37. What is sin the 3 by 5? So 3 into 5 8 are 48, 3 is 24, and this is coming in downward direction, okay, that is minus 24, and this is in this direction, negative x-axis, that is 40 cos 37. What is cos 4 by 5 into 4 by 5 8, so 8 4 is 32 I cap in this direction. So the vector notation of the rain falling is given by minus 32 I cap minus 24 j cap. This is the vector notation of rain falling, that is velocity of the rain with respect to man. So general formula already I have given you. What is velocity of rain with respect to man? See, velocity of rain, I will write here, velocity of rain with respect to man is velocity of rain minus velocity of man with respect to ground. Okay na? So velocity of rain with respect to man is equal to velocity of rain with respect to ground, this one. Velocity of rain with respect to how it is falling in vector form, minus 32 I cap minus 24 j cap minus velocity of man with respect to ground going this direction positive, that is 30 I cap. So finally what is the velocity of the rain with respect to man, minus 32 I cap minus 24 j cap minus 30 I cap. Finally velocity of the rain with respect to man is minus 30 minus how much, minus 62 I cap minus 24 j cap. Now for this if you draw, I think you can draw here this direction. See here, I will draw here how to catch hold of the umbrella xy axis. For example, now see here, this is positive x, negative, positive y, vertical, negative. Now minus 62, that means down direction. This is minus 62. 60 here, sorry, minus 62 means this x direction. 62 minus and minus 24 j cap. Okay, that is minus 24 means negative direction, minus 24 j cap. This is minus 24 minus 8. So both are acting at right angles. What is resultant? Resultant in this direction. This is velocity of the rain with respect to man, resultant. Okay, velocity of the rain is nothing but applying parallelogram law, root over minus 62 whole square means plus only, plus minus 24 whole square plus only. So this value will be around, will be getting around nearly, say minus 64 whole square plus minus nearly under root 62 square. What is 62 square? 3844 plus, and what is 24 square? 24 square nearly 576. Okay. So finally you will get a root over roughly around 4420, and nearest answer, that is almost 66.4 kilometers per hour. I can round it off nearly to 66 kilometers per hour. That means rain is falling in this direction, velocity of rain with respect to minus, that is 66 kilometers per hour. So in this direction means how to catch hold of the umbrella. This is theta, this is theta. So what is tan theta? Opposite by minus 62 by minus 24. That is equal to tan theta. So 2 3s are 2 1s are 2 12s are nearly tan theta. You can take it as roughly around 2.5. You can divide. See, 31 by 12 means how much? 31 by 12. 12 2s are 24. Okay. 7. Okay. 12 5s are 60. 12 6s are 72. Isn't it? So nearly 2.5. Nearly 2.5. That means theta is equal to tan inverse 2.5. So our umbrella should be caught hold. This is the umbrella. You have to caught hold of around tan theta is equal to 2.5. Okay, లేదా theta is equal to tan inverse 2.5. ఈ విధంగా umbrella ని మనం యాంగిల్ వెర్టికల్ తో మనం హోల్డ్ చేసినట్టుగైతే you can protect the rain. Okay, so this is the last version of the umbrella problems. This is the last version of the umbrella problems. Okay, now after this we will be going to the last concept in this kinematics 2D, that is nothing but river boat problems. That will be the last concept, river boat problems. Let us see that. So these are also coming in the examination, not only in IP, NEET examinations and also in MSET. Okay, let us discuss that last point, river boat problems in 2D. So this is the last part. So you can name this one as different names as river boat or river swimmer or aeroplane wind problems. Okay, river boat, river swimmer, aeroplane wind. So let us discuss one by one. Suppose this is river is flowing in this way. Let the width of the river be around d. Okay. Now this is the river is flowing in this one, velocity of the river with respect to ground. Now case 1, what is first case? For example, a person is standing here. He want to cross the river of width d meters. Now in how many ways he can go? Suppose if you want to go straight away, suppose this person swimmer, if you want to go straight away, you have to overcome the river, because when he is going like this, river will be drifting in this side and the person won't reach here, he will reach over here in this place. That means because the river is drifting him away, the person will be going that side, please. So if you want to reach in this point directly from A to B, he has to go in this direction at an angle theta. If you want to reach from A to B directly, the swimmer or the boat person, he has to go, because the river will be drifting in this direction. So he has to go in this direction. So what is the angle? This is the velocity of swimmer with respect to river. So here sin theta is equal to opposite by, that means velocity of the river with respect to ground by velocity of the swimmer with respect to river. So if you go in this angle, the person can go and reach to the other side of the bank. Okay, this is the first case, the angle in which he has to go. Second one, he has to overcome the drift also, because this person will be having two components. One is horizontal and another is this component. See, this component, two components, horizontal and vertical. What is horizontal here? V, velocity of the swimmer, VSR cos theta. And what is this component? V, velocity of the swimmer, sin theta. VSR cos theta, velocity of the swimmer with respect to cos theta, and this one. Now if the river is also flowing, then what happens? These two velocities should cut each other. Then only there will be no drift, otherwise drift will be there. That means the velocity of the swimmer with respect to river, whatever you got that value, should be equal to velocity of the river with respect to ground. Then there will be no drift. Drift is zero. Otherwise, the person either he has to go in this direction or in this direction. Now see here, for example, observer here on the outside, observer. An observer who is outside the water, he feels that velocity of the swimmer with respect to ground is given by velocity of the swimmer with respect to river plus velocity of the river with respect to ground. This is very, very important formula. An observer who is watching outside the river, what he feels, the swimmer is going in this direction as well as this direction. That means velocity of the swimmer with respect to river plus velocity of the river with respect to ground. This is the actual main equation for the observer outside. Inside the person means he don't have any difference because he is also flowing along with the water. He feels that the person is going straight line. But a person who is watching outside the frame, he feels that velocity of the swimmer with respect to river plus velocity of the river with respect to ground. So here, if he is not having, if you don't want to have any drift, this component should be cancelled by the velocity of the river. So these are the things you have to make a note while doing numericals. Now we will see one problem. So I think with that you can understand better the board problems. Okay. Let us do a small numerical. See, let us do a small numerical. Right, students, let us solve a small numerical regarding river board problems. Okay, now see here on the board, a river is flowing at the rate of 2 km per hour. This is the velocity of the river with respect to ground. A swimmer, you can see from this side, he has started at point A, a swimmer. He wants to cross directly from A to other side of the bank. But because river is flowing, if he starts here, then he will reach somewhere over here because of the drift. So he has to start in such a way that due to drift, the person will be reaching this point. That means he has to go with an angle theta with the vertical, the swimmer. So an observer, according to when the observer is going outside, that means not inside the water, who is observing outside, the velocity of the swimmer with respect to ground is given by velocity of the swimmer with respect to river plus velocity of the river with respect to ground. This is the main formula. That means a person who is watching outside, he feels that the swimmer is going in this direction and also in this direction. That is velocity of the swimmer with respect to river plus velocity of the river with respect to ground. Now we will try to solve this problem. Now because the person is going, going with around speed 3 km per hour swimmer. Let the swimmer is going with a 3 km per hour with respect to river. Now if you want to go here, because of river, he will be reaching here. So he has to go in this way. So what are the components for this one? One is 3 cos theta, another one is 3 sin theta. Okay. Now you can see here 3 sin theta is horizontal component and river is also giving some velocity too. So if there is no drift, then these two should get cancelled. That means here 3 sin theta should be equal to 2. Then only the drift is 0. Then the person will directly go to the point opposite side, that is point B. So 3 sin theta is equal to what is sin theta? 2 by 3. So that person has to go at an angle theta sin inverse 2 by 3, where 2 is river velocity with respect to ground, 3 is velocity of the swimmer with respect to river. Now from this we can calculate what is cos theta also. Cos theta root over 1 minus sin square there, that is 4 by 9. That is 9 minus 5, root 5 by 3. So this is cos theta. Now what is the time taken by the swimmer to reach to the other side? So take the perpendicular speed, you will get the value. Time, that means distance is equal to distance. What is the distance? 1 kilometers, width of the river. This is the width of the river, distance by speed. That means 1 kilometer by vertical speed. What is vertical speed? 3 cos theta. What is cos theta? Root 5 by 3. 3 get cancelled. That is 1 by root 5 hours. So at what time the person will reach on the opposite side is 1 by root 5 hours. Directly on the opposite. Because here root 3 sin theta is become equal to 2. The horizontal component get cancelled. No drift. Okay, so the time taken to reach to the other side is 1 by root 5 hours. Clear? Please note down this problem. This problem is very, very important. Okay, so in the examination you'll be asking what is the time taken to reach to the other side, and sometimes if drift is there, you'll be asking this drift also, that is A, B, C, this drift B, C. If you want drift, if drift is present, then this speed into time taken. If you want drift, then this speed, that is this speed means the water speed into time taken. You'll be getting the drift. So in the same way, you can also calculate minimum time also here. You can see minimum time. So how to get minimum time? Time minimum. Same formula you can apply here. Distance is equal to speed into time. Okay. Distance is equal to speed into time. Which speed? Perpendicular one. Or distance by speed is equal to time. Okay. So for example, in this problem you can see what is distance? 1 kilometer. By what is speed? For example, if you take in component form, cos, that is 3 cos theta is equal to t. So in this, the angle, whatever angle is there, theta, to be maximum means theta should be 0 degrees. Theta should be 0 degrees because cos is maximum at 0. That means the person has to swim perpendicular. The person has to swim perpendicular. That means the person has to swim perpendicular to the flow of the river. So when you go perpendicular, then the time will be minimum and you will be reaching opposite side of the river. So this is how you can solve the numericals. So let us see the last problem in riverboat problems in kinematics 2D. You can see on the board, a river is flowing with a velocity of 4 kilometers per hour with respect to ground, and the person is swimming 3 kilometers per hour with respect to river swimmer. Some angle is given 60 degrees with the horizontal. So in this question is asking what is the time taken to reach the other side, and what is the drift. Okay, so let us calculate what is the time taken to reach the other side and what is the drift given by the water. So first try to solve the components. 3 kilometers per hour velocity. What is the formula I told you for the observer outside the frame? Velocity of the swimmer with respect to ground is velocity of the swimmer with respect to river, velocity of the river with respect to ground. So observer outside, he feels that the swimmer is going this side and also this side, and water will be flowing in this direction. Now the components, what happens? 3 cos 60, 3 sin 60. What is 3 cos 60? 3 into half, 1.5. And what is 3 sin 60? 3 into root 3 by 2, that is 1.5 root 3. So the person is swimming, velocity of the swimmer is swimming how much? 1.5 this direction. That means minus 1.5 I cap in this direction and also in this direction. That is plus 1.5 root 3 j cap. This is the velocity of the swimmer with respect to ground in vector form. That is, the person is swimming in this direction, minus 1.5 plus 1.5 root 3 in j cap. But what is happening here? 4 kilometers water is also flowing in this direction. You can see here, water is flowing at 4 kilometers. So which is more? 4 kilometers is more than 1.5. So the person will go in this, net speed will be in this direction. That is how much? 4 minus 1.5. 2.5. So the net will be in this direction. Now the value will be changing. So what is the net value now? So net value is nothing but 2.5 in this direction, the swimmer, 2.5 I cap, and in this direction how much? Plus 1.5 root 3 j cap. So this is the velocity of the swimmer with respect to ground, because water is trying, because this person is trying this direction, water is drifting. So when he is going this direction, water will be drifting in this direction. So net speed will be how much? I will show here. The person is trying to swim in this direction. But what is the speed of the water? 4. So net speed is this direction. That means the person will try to go this, but it will drift like this. So finally, he will reach somewhere over here. A, B, C. So he will be reaching somewhere over here. This is the drift. Okay. Now find out the time taken to reach this side. So what is time taken? Time is equal to distance, same 1 kilometer, by vertical speed. How much? 1.5 root 3. So that is around 1 by 10 by 15 root 3, or 5 2s are 5 3s are. That is 2 by 3 root 3 hours. So the person, how much time will be taking to reach to the other side of the bank? 2 by 3 root 3 hours. Now how much drift is there? Because water is drifting. Because he is trying to go in this direction. Water is drifting. So the net speed will be this direction, 4. How much? 2.5. So 2.5 kilometers per hour is the net speed. Okay. Now the final drift will be how much? Drift is given by speed, net speed, 2.5 kilometers per hour into time, 2 by 3 root 3. So again you can get 2.5 into 2 means how much? 5 by 3 root 3. So this is the drift given by the water for the swimmer. So this much distance the person will be drifted. After starting from here in this direction, because of drift, he will be coming this direction. So what is the drift BC finally? 5 by 3 root 3 kilometers is the drift of the person. Clear? All of you? Right. So this is the value of drift and this is the time taken. And you can also calculate AC also. You can also calculate AC. Because already you got this distance BC, 5 by 3 root 3. You know this distance how much? 1 kilometer. You know 1 kilometer. You know BC. You can calculate AC also by using Pythagoras theorem. What is Pythagoras theorem? AB square plus BC square. This value AC can be calculated u over AB square plus BC square. You will get AC value. So you can also get AC value also, AC distance. Okay, by using Pythagoras. So this is how you can solve the river boat problems or river woman problems or aeroplane wind problems. Again we will be meeting in the next chapter, that is 4th chapter, Newton's laws of motion.